In this video, we are going to implement API pagination in Spring Boot using JPA. We are going to showcase both pagination by page number and also by cursor. And we are going to discuss a couple of pitfalls that we need to watch out for. As usual, the source code and the URLs that we use in the video will be linked in the description below. And if you want to support the channel, please like the video or consider subscribing. There's a lot of Spring Boot content already on the channel and more coming up. Thank you. We are going to start by initializing a new Spring Boot project using the Spring Initializer website. So you can search on Google for Spring Initializer. We will use Gradle, Kotlin, all the videos on this channel. We usually use Kotlin, Spring Boot 3.0, which is the latest stable version. The project name will be Pagination. And for dependencies, we need to add developer tools. As usual, it has hot swapping and it makes development easier. We don't need to restart the project all the time. Then we need to add Spring Web because our project will return a REST API. We also need to add Spring Data JPA and Liquibase for creating the database migrations, and also MySQL driver because we will use a local MySQL database. This looks good. Now we can generate this project. It will ask us to download a zip archive so we can save it, extract it, and next we can open it in IntelliJ IDEA Community Edition. This version of IntelliJ IDEA is free. You can download it and use it. It's very good. So this one right here, and it will index for a couple of minutes, and I will skip ahead in the video. Okay, in order to keep the video short, I already added a migration to our project. You will be able to find it in the video description below and add it to your IDE. So just to briefly take a look at it. So we have this, we have one change set in it that creates one table called produce. And this table has 3 columns. There's ID, which is the primary key of the table of type integer, and it auto increments. Then we have the name of the of the item, which is a string, and also each item has a rating, which is of type integer. And then I added 10 items to the table. So we have apples with rating 4, oranges with rating 1, etc. So all these ratings are from 1 to 5. And once we execute this migration, we will take a look exactly at the data. But now we need to populate application.properties and start this project. So in here we can do Spring data source URL, and we need to provide a JDBC URL. So JDBC MySQL, no, it's actually single colon MySQL, and we're going to use localhost 3306. And we will use a database called Pagination, which doesn't exist. We will create it. Then we'll use Spring data source driver class name. It will be the MySQL driver, and then we need to provide the username and password. So username is root. Data source password. Usually you should put this password in an environment variable, but for now it's just running on my local host and I don't have a password in here. If you do have a password, you can type it in like that. Then we do Spring Liquibase enabled equals true. Spring Liquibase, I think change log, and we need to provide the path to this file in here, so we can just copy path from the sources, so that one like that. And that's pretty much it. So now we can just run our project. Oh, actually, first we need to create the database. So we will open a terminal, going to connect to the MySQL running on localhost with the root user, or you can connect with other user that can create databases and has enough permissions. So in here we create a new database, Pagination, and we can connect to this database, and we will see there are no tables right now. So if we run the project, we go to the pagination application.kotlin and execute start the project, create a new running configuration by clicking on this little triangle. So yeah, we see that the project is started successfully. And now if we do a show tables in our database, we see that the tables from Liquibase were created, and also the table produce. We can take a look at the data in our table right now. So if we do a select star from produce, we will see that we have 10 items, and they all have a rating between 1 and 5. And actually the API method that we are going to implement pagination on, it's going to be called top produce, and it will return them in a descending order of their rating. So it will be something like select star from produce, order by rating descending. So we can see in here that we have 2 items with rating 5, 2 items with rating 4, 2 with 3, 2 with, and there are 2 of each rating value. The SQL feature that we will use for pagination are these 2 arguments of the select statement called limit and offset. So if we search for MySQL select syntax, we will see in here that there are these parameters limit and also offset. So the way this works is that we use the same select as before, and let's say if we want the first 5 items, we do limit 5, so it returns the first 5 items. And then if we want to get the second page, we can do offset 5. So this will return the last 5 in the sort order. The first pitfall that I would like to discuss, it happens when we don't have a stable sort ordering. And this will happen when we can have equal items according to our ordering criteria. And in our case, let's say we only fetched the 3 top items in our table. So in this case, we got the ordering carrots, pears, apples. But if we do another top 3, we can also get the ordering of pears, carrots, and apples. It's also valid because pears and carrots are equal according to our order by rating descending. And this can be a problem around the edges of pages. So let's say we got the first page, and the last item on our first page was tomatoes with a rating of 3. But then if we do a second select with an offset to get the second page, we can still get tomatoes because blueberries and tomatoes are technically equal. They have the same rating. And you can see why this is not a great user experience. The way to address this issue is by adding sorting criteria that is unique, such as the primary key of the table. So in here, we will order by rating descending. And in case of ties, we use the ID, which is guaranteed to be unique as the primary key. And now we will see that we have a stable sort order. The second pitfall that we need to watch out for happens when we don't have our table indexed by our ordering criteria. In this case, for every page we fetch from the database, MySQL will need to scan the entire table. And this can be a problem, especially when our tables are big, like thousands of rows, tens of thousands of rows. Let's say we want to see what the highest rating in our table is. So we will do a select rating from produce, order by rating descending, and limit 1. And we will see the rating is 5. But if we want to understand why MySQL does behind the scene, we can add explain and then let's say format tree in front of the select. And we will see what it does internally. So first, it will scan the entire table, the entire 10 rows. Then it needs to sort all these rows by rating descending, and then just pick the first row. So this makes sense because MySQL keeps the table ordered by the primary key by default, unless we add a secondary index. So you can see that it needs to scan an entire table and sort it just to give us like one value. For fixing this issue, we will create a secondary index on our table ordered by rating descending and by ID ascending. And we'll do this in our Liquibase migration. So in here, in liquibase.xml, we will create a second change set at the end of the file. Let's say ID2, Vlad, and we need to do a create index in here. The table name is produce, index name, we will do IDX, rating and ID. So the first column will be rating. And we also need to do descending equals true. Close this one in here. And the second column will be ID. Okay, this looks good. We need to restart our project. Okay. And now if we, in MySQL, if we run the explain again, we will see that it only returned one row directly from the index, and it didn't have to scan the entire table, sorted all these heavy operations. So you can use explain to analyze other queries in your database, but if the table is very small, MySQL won't use all the optimizations. So on small tables, take the analysis with a grain of salt. We will now continue by adding the Kotlin code to our project. So we'll add everything in this pagination application. First, we need to create the entity. So we'll do a data class produce. And this one will have 3 fields, ID of type long, then name, string, and rating, also long, and will be annotated with entity. The data class, the ID will be annotated with ID, and also with generated value. And a strategy generation strategy identity. We need to add this for MySQL. There are multiple types of repositories in JPA. If we search for a JPA repository, we will find this interface, which is the base interface from which the other repository types are derived. So we can see in here repository, which we used in other videos, CRUD repository. But the one that allows us to use pagination is this one right here, paging and sorting repository. So we will see that this repository will have methods that take as argument a pageable object. So a pageable object is used by JPA to compute the offset and limit values that will be passed to the select statements in MySQL. So a pageable is an interface, but in order to create pageable objects, there's this helper class called the page request. So if we look into page request, we have these static methods, page request of, and we specify the page index. So we can say page number 1 for the first page, and the pagination size. And also we can also pass sorting criteria to the pagination requests, which will then be passed to the SQL query. We can now try this out in our project. So we'll add a new repository in here. Interface produce repository of type paging and sorting repository. So the templates are produce and the key type is long. It's this one from here. And then we can use this repository in a new controller. Let's call it produce controller. And we need to wire the repository like that. This one needs to be annotated with the REST controller. And in here we will have one function, let's say top produce. We want to get the pagination, the page information for now in the endpoint. We'll just return the first page to make sure it works. So in here, from produce repository, we call the function find all, and it will be page request of. So let's use the first page of size 5, and we also want to pass the sort. So let's say sort by. So we need to sort by rating descending, and by and sort by ID, like that. And now this find all method will return a page object, which we then need to convert it to our result type. For now, our result type will just be a list of the produce objects. So we need to convert the page to a list of objects. Let's say I think there's a method in page to list. Let's see what is. Oh yeah, we don't need it. We just can convert it directly to list, like that. So now we just add a get mapping on a function. The path will be top-produce, and now we can just rebuild our project. And because we added DevTools as a dependency, it will just be hot swapped. We can try out our API. I will use Postman, but you can use other API clients. So in here, if we do localhost 8080. Yeah, this one slash top produce. Yeah, so actually we see that we get the second page. It starts with rating 3. Our top, the first page will have, will start with rating 5. And yeah, this is a common gotcha. Let's say the page request indexing starts at 0. So when we say page 1, it's actually the second page. So in here, if we change it to 0 and we rebuild our project, and we try it again, we will see that we get we'll get the items with rating 5 first. We can now finish our endpoint. So we need to allow the API client to specify the page he is fetching and the page size. So we will have 2 arguments to our function. It will be page of integer and size also an integer. And they will both be request parameters. So request param, they will have a default value. So by default, we fetch page 1 if he doesn't specify this. And also for size, it will also be a request param, but the default size we will use is 5. And now we need to pass them in a pagination request. So the pagination request is 0 indexed, but what we are returning to the client will be 1 index. So we need to subtract 1. So page 1 for the first page for the client is page 1, but the first page for JPA will be page 0. So we need to make that conversion. And here also we just pass size to page request. And now instead of returning just the list of the objects, we also need to return to the API client whether we return the last page in the repository or not. So if he needs to continue pagination. And for this, we need to create a data class that has both the items and this Boolean value, whether it's the last page or not. So we'll make a data class in here. Let's say produce response. So we'll have items, an iterable of produce that will have the list that we were returning before, and also the Boolean has next. And now we need to convert this this object that JPA returned. We need to convert it to this new data class, and we will do a let in here. So we see the type of object. It says page of produce. So we will make a produce response, and items will be the toList value and has next. We will just pass the has next value from the page object. This looks good. So now we can just rebuild our project. Okay, let's check it out. So in here, we will see we have the items and then also the has next true. And if we pass in inside query params, let's say page 2, we should see the second page like that. And yeah, it says has next false. So this is the last page. And also let's see if size works. So if we pass, for example, size of 3, we'll remove page for now. You can see in here how it changes the URL. So if I add page, it adds page 2 to the URL. Just in case you're not using Postman and you're just changing the URL in the browser. So now if we do page 3, yeah, we see we get 3 items with has next true, and yeah, we get the 2 with the rating 5 and 1 with rating 4. So yeah, this is this is one method of returning pagination results to the client. The problem is that the client needs to keep track of the current page he is on, and if this value is true, increment the page, fetch the next page, and so on. There are other ways to implement API pagination. In some versions, there will be a URL in here that you can that the client can use to fetch the next page. We are not going to implement this method in this video. Instead, we are going to implement next pagination by cursor. So in here, there will be a field called cursor, which is a string. It's usually an object base64 encoded, and the client needs to take this string value and pass it to the next request, and so on. When this cursor field is null, that means that we reach the last page. So you don't need to send another request. Okay, so we'll implement cursor pagination as a new endpoint. This means we need to create a new response object in here. Let's just copy this one for now. And we're gonna call it produce cursor response. And we're gonna replace this has next with the cursor. So it'll be cursor, which is a nullable string. So string with question mark, it can be null or it can be string or a null. And in here, we'll make a new, let's call it top produce with cursor. So in here, cursor. So we're just gonna add a cursor in here. And instead of page, we need to get a cursor from the client, which is a nullable string again. And yes, it won't have a default value, so it can be nullable. And again, we need to keep the size because we need to pass it for the first request if we want a different pagination size. Now we can work on the code. So we're just going to start with the code from here. We need to do a produce repository find all, but we need to figure out what pageable to pass. So if the cursor is null, then we need to create a pageable for the first page in the repository. Otherwise, we will fetch this pageable from what is included in the cursor, and the cursor will contain the current page number and also the page size. We will encode them both as a base64 string. So we will create a utility object in here. Let's call it page util. So in here we will have a function, let's call it function from cursor, that takes a string cursor, this time not nullable, and returns a pageable. And we will fill it later. Let's just return null for now. So in here, if the cursor is not null, we use this function let from Kotlin. So the question mark dot let, it will only apply to cursors that are not null. So in here we will do page util from cursor. This will create a pageable. And otherwise, if the cursor is null, we need to create a page request for the first page. So page, actually let's just pass everything in here. Let's say first page, and we need to take as argument the size, and again it will return a pageable. So we will be a page request of page 0, the size will be size, And we also need to pass the sorting criteria. So in here, that one like that. So we will do, if the cursor is null, we do first page util, first page of size. Now we need to build up the response. So in here we do conversion with let, just like before, but now we need to create a produce cursor response. So items is the current object to the page object to list, just like before, but now we need to create a cursor field. So if there's a next page, then we need to encode the next pageable as a string. So we will create a utility function again. So let's say create cursor from a pageable, and it will return a string. And for now we'll just return an empty string. We'll fill it up later. So if there's a next page, then we will in the cursor we will put this function create cursor from, let's say, next pageable. Otherwise we just we put null in the place of the cursor. And lastly, we need to actually work on the utility function that we created before. So the first one is we need to take a pageable and convert it into a string. And the way we are going to do this is we are going to put the page index and the page size inside a byte buffer in this order, and then base 64 encode them. So in here we are going to create a byte buffer, let's say byte buffer, and we need to allocate enough for 2 integers. So integers size in bytes times 2. And then in this byte buffer we will put 2 integers. So the page, we put the page number, and also we put the page size. And then we just encode them with base 64. So it will be base 64 encoder. So we will return in here encoder dot encode to string. So from we will get the byte array from the byte buffer. And we need to do the reverse when we are deserializing a cursor. So in here we need to create a base 64 decoder. So let's say decoder, and we need to decode decoder.decode the cursor. And I think this one returns byte array. So we'll wrap this into a byte buffer. Let's say again byte buffer dot wrap, and this result that we got. And now we just return, we parse the 2 integers. So a page, there will be return page request of, so the first the page number will be the first integer will be the page number, the second one will be the page size, and then we also need to add this sorting criteria as the third argument. So yeah, that should be it. Now we can just rebuild our project. We can try it in Postman. So our new endpoint is called top produce cursor with dashes. So in here, if we do this one, that dash cursor, so we will get the first 5 items, and then there's also this field cursor that if we pass as a query parameter in here, we see we get the second page with the rating 3, and it ends with rating 1, and then cursor is null, so this worked correctly. And we can also control the size. Let's try size 4 and remove the cursor to get the first page. So in here we will see that we get the first 4 items, and if we pass the cursor we just received in here, we will get the next 4 items, and then if we pass the new cursor we will get the last 2, and the cursor is null. So it worked as expected. There are a few things to iron out before this can be production ready. So in here, when we parse the cursor that we receive from the client, we have to handle the exceptions. Like they can add characters that are not base 64, or there can be insufficient bytes or more than expected, and then these numbers, they can be negative. So you need to handle all these situations. And if anything funny happens, then you just return an HTTP 400 status bad request. This is all the material we have for today. There are more videos on Spring Boot and Kotlin on this channel. Some of them will show up on the screen. If you run into issues, post in the comment section below and I will try to help you out. Thank you for watching.